So over here, we start with omega x equal p over a because you're given 1,000 force and we're given 1,000. And you might be asking, what's the question asking? Is question asking the decrease of the diameter of the applied force. So we're given p over a. Next, what we do is apply it with omega x divided by epsilon x equal E. Why do we go with that? Because it gave us the modulus of electricity, which is E. After we have that, we're given the possibility of using Poisson's ratio. So it did give you that, which is negative epsilon x or y. No, sorry, y or z, and epsilon x. Now, another way to write that is negative is epsilon r over epsilon x because this is the polar coordinates. After that, you multiply epsilon r by the diameter, which will give you the delta version, delta diameter or something. That's the whole roadmap, okay? That's now let's read the question. A 25 millimeter diameter aluminum rod is loaded axially in tension. I don't really like axially. I don't know. The ly seems wrong to me. In tension as shown, aluminum has a modulus electricity of 69 gigapascals and a Poisson ratio of 0.35. So with that said, we can do this now. We begin by doing the force, which is 1,000 divided by the area, which is pi parentheses 25 divided by 2 multiplied by 1 divided by 1,000 because it is in millimeters square. We grab that out. So we have 1,000 divided by pi parentheses division 25 divided by 2 multiplied by 1 over 1,000. And then we parentheses square that. We get about 2037. I know there's a shortcut called the play and other stuff. Like PL divided by LA gives a shortcut sometimes, but this one, you can't do any of that. So, and then we do epsilon x over epsilon x equal E. But remember, if you forget that, there is always a way for you to just write it down by just looking at this stuff. Oh yeah, here, play. There's a shortcut. But that doesn't work over here, so don't try to use this equation yet. That would fuck you up very much so. So I would recommend you start over here, which gives you E, epsilon x equal omega x divided by E. So you grab the equation from the before, and you do 29 multiplied by 10 square root of 9, which gives you about 0.00. I get 0.000 0295. I'm going to show you a shortcut soon. Because the step right here when we do epsilon r divided by epsilon x equal negative position Poisson ratio. This you can do epsilon, we know epsilon x, right? V equal epsilon r. And you could have implied that into here and solve for epsilon r right away, basically saying shortcutting a little bit of it. What you do is basically multiply by Poisson ratio already to save yourself some time. But I'm not doing that because we're showing steps here, not easy methods to just, I mean, we can do the easy method, but it doesn't matter because we still get the same thing. So negative 0.000010334. Now, you can see how long these numbers are. So it's very important for you to keep it in your calculator. By keeping it in your calculator and making it correct, you can like use the answer from before to get the answer afterwards. Uh, Let me just, you couldn't see that, huh? And so 0.0000103. Anyway, with that being said, what we can do afterwards with the knowledge that we got epsilon r is epsilon r d equal delta d. So with that said, we can do delta d equal whatever epsilon r is multiplied by 25. Divided by 1 over 1,000, obviously. That's not you know, that's a given. So we can do negative 0.000, I should probably write it over here because I keep on making the mistake of having my camera open for some reason. I don't know why when you share it, it shows your face. Like I don't really need that. But that's what happens when you do that. Anyways, division of 1 over 1,000. Oh wow, that's like tiny. Um, so tiny that my calculator has a problem registering it, unfortunately. Wow. That's not what I expected myself to say, but it seems to have a problem registering it. So I might need to shortcut it a little bit. But this is what my calculator showed, 0.0000060, I guess, by 258 equals negative delta D. Now, I'm thinking I might need to use one of those times 10, so like 258 times 10 to the negative 9 would be equivalent to saying that, which is saying, this is meters, equal to 258 nanometers, which is about 8. That is a lot of small numbers. I might need to actually make sure to use one of those small, the tens, which I will now, I guess. If the rod decreases by, did it? Um, uh, that implies that using part two, you can get part one because that's a little cheesy in my opinion. But now you can double check your answer. Didn't expect that to happen. While the length increase, what is the percent change in volume of the rod? Okay, so you have this, right? Decreasing over here, right? But the question is, you kind of have to also imply the deflection at point X. So what I'm trying to say is we have to use the play equation now. This over here needs to be used. You might be asking, why can't we use the play equation earlier? Well, this is a deflection in the x-axis. It's not the deflection in the other axis. So that's fair, right? So with that said, we can use a volume analysis to figure this out now. Um, so diameter equal to 5/8, and then the length has to be changed here. So P is 1000 multiplied by L, which is 1, divided by pi r squared, so 25 divided by 1000, multiplied by what? Oh, that's it. No, divide by 2, because it is radius we're looking for. Um, no. Wait, yeah, that's correct. E is 69 times 10 to the what? 9 power. So here we are. So we have 1000 divided by pi multiplied by division, parentheses this 2 because we're going to square root this thing, square it. 25, 1000 multiplied by 2, divided by 2, but my calculator looks like, well, it doesn't matter. Multiplied again by 6.69 times 10 to the power of 9. Okay, I get about delta x equals 0.0000295, something like this, which is way less than before, which is better than before, I guess. So this is a positive, and this is a negative, negative, right? So all you have to do is delta plus and then delta minus, and we can figure this whole thing out, basically. And that's what we're gonna do. Yeah. So here's what we're gonna do. This is delta, by the way, not that. So we're gonna do volume minus volume initial divided by volume initial multiplied by 100% equals that. So the new value, so this is gonna be new, V new and V old. V old is equal to whatever this is, 1 multiplied by pi, and what is r? R is 25 divided by 2 parentheses square, right? Oh, I'm gonna have to change to meters again because that's how we roll now. Divided by 10, 1 divided by 1000 over here, and that will give you the answer to that one. Oh, we don't forget the square. Anyways, the new one is gonna be a little different. It's gonna be 1 plus epsilon x multiplied by 1 plus epsilon r, which is a negative, by the way, squared, and it's gonna be pi, and that will give you it. So that one you're gonna grab a calculator and do it. Let me just do the 1 plus whatever this is, 0.0. That's like so tiny. It's gonna be a very tiny number, that's for sure. 1 plus whatever minus. I remember like having like a this. I didn't put a negative on top, so negative that parentheses square multiplied by pi. Okay, that's a good number, I guess. I hit literally almost pi, which is interesting. Um, Oh yeah, that kind of makes sense because you did minus that. Okay. And the other one is 1 multiplied by pi, parentheses division 25 divided by 2, multiplied by 1 divided by 1000. Oh wait, I'm so stupid. Sorry. This is not right. This is supposed to be 25 over 2. My mistake. That was why it was so tiny. Square, right? Okay, let me just check this. Division 25 divided by 2 multiplied by 1000. Okay, this is also one that has to divide by 1000 here. 1000 parentheses. I forgot that. Um, so the new one versus the old one, it is decreasing, although that is facts. Divided by this. Ooh, okay. I get a very, very small number. Um, yeah, let me double check this just to be clear. Apparently, I got the right answer. It's just that once again, it's the calculator rounding issue because I did not round anything. I checked it 100 times. I get about 0.001%, and that is actually B. I didn't realize it was B because I wasn't getting 0.0009, but apparently it was a rounding issue because of how small these numbers are. There's bound to be rounding issues. I was getting like 0.00001, and I was like, what's going on? And then multiply by 100 and I get 0.001, and I was like, that's not right. There's no digit like that, but it's a roundup issue. So apparently sometimes there will be rounding issues in here, but yeah, I got the answer right. I was like, okay. All right, the next question we're up against is doing this one. What's the total strain energy in the rod? Total strain energy. Okay. I know what it is, but is I think it's like if I remember correctly, it's like one half U delta squared or something. U P no, one half P delta squared or something like that. But let's check if we have it in here, because if we have it in here, we don't have to memorize it for you guys. But if it's not here, then I will give you the equation you have to memorize for it. Um, but I'm hoping that there's no memorization needed because I don't like memorization. I absolutely I mean, don't load it, but I don't like it when you have to memorize everything because there's like 16 sections here. There's no way you're going to memorize like all 16 sections. But honestly, because I've been doing this for a long time through my college career, there most of these equations have been memorized in my head because all the teachers have taught it one time or another. Um, but it'll be nice if it's here because if it's here, then I don't have to give you anything. You can just take it. Ah, here it is. So you can see over here that this is over here. If here's a elastic strain energy, and if the strain remains with a elastic limit, the work done during the deflection extension of the member will be transformed into potential energy and can be recovered. So it means that if you're under the E location, if you're above the E location, you're done. You're just done. Okay. But if you're in a linear section and not in the deformed region, if you go over here and come back, you can't use this equation anymore because you lost a lot. But here is when Hooke's law can be used. And basically, if Hooke's law can be used, we're all good. So we come over here, and basically, what is the stored energy? Basically, it is, you can call it U equal or the work or equal one half of P delta square. With that said, it means that one half, whatever P is 1000. And then we can use the play equation over here. Oh, is it delta or delta squared? Um, yeah, delta, my apologies. It's delta. I make mistakes all the time, man. We can use a play equation. Because PLAE is what we used because it is we're asking is total strain energy in the rod as a result of the loading. Well, they should really indicate what the delta is. The delta is a tension in the elongation, but they should really explain which delta it is. This delta is the delta of the x direction, or the direction of being pulled. But I guess part of being an engineer is knowing that. But certain times you need to memorize, sometimes you don't. Pi 25 divided by 2000 again, squared elongation of 26 times 10 to the 9. Okay. After this, I'm going to be a pro of those G and M figures. I already was because I took so many classes with this. Like, there's been like so many like classes doing this stuff. Man, it's ridiculous how many classes like I've been doing this. Like, yeah, to 9. Okay, I get 0 point. Well, I think I missed something because that doesn't seem right. I forgot to divide by 2 or something. Why I say that is because I got a number, yes, but it seems like I got something. 1,000, 0.05 divided by 2, squared, 20. Oh, wait, it's 69. The reason I was saying is because I got none of the answers. Let me change that 69 over there. Yeah. I don't know where I got the, yeah. To tell you the truth, I've been doing these videos in a row after row after row, so I am hallucinating a little bit. So apologies for the hallucination. Like this is not my best form. Okay. I get 0.0147, which is 0.015, which is B. Yeah. I've been doing these videos consecutively basically, and little to no breaks in between. So yeah. Next question is the 10 by 5 rectangle steel plate is loaded in a compressed by two opposing triangle distribution. Okay. Um, okay. as shown. Okay, steel has a modulus of electricity of 2.1 times 10 to the 11, and a Poisson ratio of 0.3. Buckling is to be this. Oh, yeah. Here's the thing about buckling. Buckling is another power. You know, in these triangles when we did the truss, there has been a lot of times when you remove stuff in between. The reason that we have those things in between is actually because of buckling. But if we don't assume buckling, a lot of things get deleted, and a lot of things don't matter. Yeah. So, anyways, we're gonna disregard it. What is the shear stress tau xy along the AA? Um, so load. So I think there's a trick to this question, and I hope I'm right. Um, if AA, because I remember neutral line over here, it feels like this is like a neutral question, which means the answer would be 0 pascals. Um, so this is the line where nothing happens and whatever. I just don't understand why the question will give you like 16 information strands. So this is pure compression also. So, so there's zero stress, right? Yeah, there's zero. There's nothing. I'm just going to assume that they were trying to do a trick question again and make you overthink this question, but I think this is B because this is I'm assuming the AA you're looking for at the shear line, and that if you're in the middle, that is the shear line for it, rectangle steel plate, and there's no stress there because it's the principal line. And that's one of the few things you have, one few things you learn in, I forgot which class. A thin-walled pressure vessel is constructed by rolling a 6 mm steel sheet into a cylinder shape, welding the sheen within line A and B. The clamp at the end, the vessel is subject to an internal pressure of 1.25. What is the normal of the line A slash B? So first thing we're going to look at is the hoop stress equation, which we can figure out over here, which is pressure R over T, which is equal to pressure tangential, and pressure A equal PI R2T, and A probably some kind of principal stress over here, and that makes sense. Here's the thing, what we're gonna do, because that is the principal stress over here, we're just gonna do a line like this, draw like that, draw like this, and basically, I'm pretty sure that X equal this, right, tangential, and this A equals theta Y. Okay? And is said over here tangential loop stress, radial stress. So that makes sense, right? Radial stress is going that way, and the tangential stress is going tangential to the hoop, which, okay. All right, but obviously we need to make a coordinate transformation because this is where it matters, where it's normal to it, and that is what we're going to do later. But before we do anything, there's like in this question, there's a way to solve this, and I don't like it. And the way you solve it is through this equation. And obviously there's no tau, but there's no torsion shear stress, so you don't have to worry about that. But you know why I don't like it? If you go all the way here, I've been searching for hours on trying to find this thing. The only thing we can find is this thing that's close to it. But there is no equation over here that has cosine and sine like that. You can memorize it for sure. I'm generally saying you can. I'm not saying you can't memorize this equation. But here's the thing. You don't want so many things memorized in your brain. There's a bunch of things to memorize, and I don't think this is something I would want to memorize here. So let us solve it in a way that doesn't need to do that, okay? So first thing to do is fx equal theta x a cosine 30, right? Because we need to get the cosine of that. And f, yes. So if we were doing the horizontal force, hold also continue force about the horizontal direction, which is going to be Fx equals stress multiplied by the area. And this is like a common theme over here. And it's Fx direction, so cosine is correct because this over here is 30. So if we were to do that, this is 30. And you kind of get the gist of what I'm saying. With that said, Fxn equals basically Fx cosine 30 again. With that said, that kind of makes it seem like there is two 30s, right? So that makes it so that it is equal to sigma x a cosine square 30. Now Fy equals sigma y a sine 30, which equals Fyn equals sigma y a sine square 30. And we are looking for the normal stress at the line AB. So what this equals in turn is that if we figure out sigma and a, that is equal, because that's just F, to saying sigma x a cosine square 30 plus sigma y a sine square 30. So we're doing a summation of force. We cancel out all the area, and we get this form over here. Sigma n equals sigma x cosine square 30 and plus sigma y sine square 30. Now we plug all those in. We already know sigma x, sigma y, and we can get sigma n by in turn. You could have, genuinely, you could have done the more obvious way of solving it, which is basically just plug into this formula over here and get an answer. Now the problem with that is there is seriously, where is that in the FE handbook? There isn't. I couldn't find it. So for this question, I was thinking, well, if I can't find that equation in the handbook, I am not sure if everyone wants to memorize that for a test that you genuinely only need to get like 50 or 60% right to pass. I don't feel like that's reasonable to ask a person taking the FE exam to memorize. So I said, well, what can we memorize is a summation of forces. And a summation of forces, we know that Fx is over here, sigma x, and we can get a cosine, and then we can do a n, which is going to make a cosine another one of 30, if I may. Like this is called x n y n, right? And then we can start from there. So I'm doing a coordinate change over here to sigma x n and sigma y n, like that, right? Now that I feel like is reasonable to ask. And then, but we don't need sigma y, we just need sigma n, by the way. We're only looking for that. So we did that, and then we got this form. Because FA, A is the area in between the F and the area of the little bit over here. And that is equal to sigma x cosine square 30 and then sigma y a sine square 30. And that, I think, is reasonable to conclude is a way to do it. Do I like this question? No, because this question is a little bit iffy in my opinion. They should have done something else in my opinion. They shouldn't have done this question. This question is a little bit unfair to you, in my opinion. So let us solve this now. Yeah, especially with the these part. This part is not unfair. This part is, in my opinion. But that's not my place to judge. If the test people are listening, please change it. Anyways, we have P, which is the force. No, pressure. Sorry, there's a pressure. What's the pressure again? 1.25 multiplied by 10 to the square root of 6 multiplied by 0, 0.2 0.45 divided by 2 by the thickness, which they did give is 6 divided by 1,000. Yep. I get 46875. Okay, yeah. Hope I'm right. And then we do the same thing with the other way, but we have multiplied by 2 in the denominator, which is about 2343750. And now we plug into this equation over here, which is much more reasonable in my opinion to figure out. I still think it's unfair for you guys to do this, but that's my opinion, not the test maker's opinion. So don't at me, but yeah. So cosine, unless they put it into the handbook. The handbook is like 500 pages long. I don't understand why they can't make it bigger because they clearly can make it bigger. Like yeah, multiply by sine 30 parentheses square. So yeah, I don't understand it. I get 41. I get in the end if you plug this in, I get 41,015625, which is 41 megapascals. As you can see, this question I don't like, but it's a valid question in the FE exam board. So screw everyone is what they're saying. You could, in theory, memorize this. I have memorized this. Oh, so there's no tau xy because there's no shear needed because we're not caring about the normal shear. We're doing a normal stress. We're not doing normal shear. If we were doing the shear force, then yeah, it did matter. But the normal stress on the weld can be computed from the hoop and the axle stress. There's no torsion shear stress, basically, is what's saying. Which, yeah, that's true. Again, we're gonna move on now, but this is a question to review definitely. So we're doing this again. Um, okay. A shear pipe fixed at one end is subjected to a torque. This torque equals 100,000 newtons per minute meter. Steel has a modulus of electricity of E equal 2.1 times 10 to the 11 pascals. The Poisson ratio is 0.3. What is the angle of twist of the pipe? Angle of twist. Yes. If they don't have the equation for angle of twist, I'll be pissed because that is a classic equation and should not be jeopardized at all by that. Over here it is. Thank God you have it. I would have been actually tripping here if you didn't have it. Now, if you don't have the G equation, I will also be tripping because no way in the world They're supposed to make me memorize it? Please, come on. You can't be serious. Ah, here it is. Okay. I was about to say, if you're about to make me memorize this equation, I guess it's plus then okay, I will. I will. I'll just dislike you for the rest of your life, just so you know. Whoever made the test, I have eyes on you. You are gonna get you're gonna I'm not sure what to say. Okay, now we need to get J, and please, for the life of me, do not say I have to memorize J too, because you're killing me. You're joking me. I know the equation. It's like d to the fourth power or something, but I don't want to memorize that. You're joking. You're joking. Where you're trolling me now. Give me 5 seconds to find this. There's no way they didn't put this in here. If they did, where's J? Seriously, J is not here? Okay, that's alarming. Oh wow, they seriously didn't put it in here. I am shocked that they didn't put the formula in here. One more check, and before I do it, I should probably pause it now because it's taking a long time to search this. And this time I think I need to do a thorough search because polar moment of inertia of a column should be here, in my opinion. So let me do a really thorough check and I'll come back. Look where I found it. It is here. Wow. Guess where it was? It was in the static section. Beautiful. Great. So now we know where it is, hopefully. Yeah, it's over here apparently. It was here the whole time, which, alrighty. So basically we do 35 divided by 2 and 34 divided by 2 equal B and equal A and plug into here. Okay, it took a long time because I couldn't find it. All right, all right, all right. I had to go to the static section. So note to yourself, go to the static section and go to the material section when looking for questions about these stuff because sometimes the moment of inertia and the other stuff are not in this section, but in the previous section before it. I don't know how I don't need to know. We'll just plug and chug now after we do some we do some actual fun part, which is basically getting the answers from this. So we can do how do you want to do it? Do you want to do it algebraically where we actually put everything into here, like basically TL divided by like this fun equation over here, e to 1 plus mu. This doing it this way makes it look so much scarier when it's not. Pi a equals 35 to square. Basically, when I do it this way, sometimes making it scary is the point of the whole entire process. And then there you go, that's how you do it. Or you want to do it the step by step and actually make it readable. So first of all, G, let's just do the G part. I think I want to make it readable, honestly. I don't want to deal with the pain of having to make the calculator like 11 letters long. It's worse for me, and also it doesn't get the correct answer half the time because you make a mistake here and it's like a death sentence to you. All right. I get an insanely big number for G, which makes sense because Young's modulus is also huge. Always does 9.0769 times 10 to the 10, apparently. Okay, let's get J over here too, because why not do it step by step, like a gentle breeze or gentleman, I don't know. Either one you have to think about. I don't know which one you think is more appropriate in this situation. Either one probably is appropriate. I'm just overthinking it. Anyway, 34 divided by 2, parentheses, square. I'm just happy we're getting somewhere. It took this long for me to actually figure out where it was. Oh, I made a syntax there too. God damn it. Where did I make a sentence there? Oh yeah, over here. All right, 27. I get, interestingly enough, that doesn't seem right. Ah, yes, I need to divide this by 100, divide this by 100. My apologies on that. So it's 200, 200. I get, okay, I get like a zero. Hmm. It should be very small. So it should be maybe yeah. Give me a minute. Oh wait, this is 33 by the way, because okay, that makes sense. Okay. Yeah. And also make sure to do power of 4, not power of 2. Makes there 0.00003089996 is our answer for that. So now we put all those things in here, and this is 4. This is 4. Okay, now that you can note, make sure to be careful about your units. Just make sure. So 10,000. And also these leftover things do confuse you, so make sure to clean them up whenever you can. Um, L is 3 divided by G, which is 8.00769 times 10 to the 10. Okay, 7 over here, but it doesn't matter. It's such a small part of it. It won't even matter. Whatever that equals. I mistyped something, I think, a little bit, but it shouldn't matter because it's in between like two big numbers. 8.0769 times 10. What I mean by that is I mistyped one of these over here. Digits, that's like 100, so it doesn't really matter, hopefully. Multiplied by 0.0003, 0.8996. Okay, I get 0.0, okay, I get 0.012020532, which is C. It is C. All right, a 5-meter long steel bar with a cross-section area of 0.01 meters cubed is connected to a spring as shown. And the spring has a stiffness of 2 times 10 to the 8. And an initial what was it? As a stiffness of okay, an initial undeformed the bar is fixed at its base, basically. The temperature of the bar is increased by 70 Celsius. The steel has a modulus of elasticity of 210 gigapascals and a coefficient of thermal expansion of 11.7 times 10 to the negative 6, 1 over Celsius. What is the resulting force in the spring? Okay, we got this. Basically, the first thing you have to do is look at where it is at this point. Let's look at the forces here. So there's a force going up from the thermal expansion. There's a force going down because of the spring. And it's technically in equilibrium because it is forced by the boundaries of the walls. Huh. So that implies everything. So delta T plus delta of let's call it P must equal, wait a second, delta total. Delta total must be K equal force, and we will transform to P because we're going to use the play equation, and we need to do that really. So here's what we're going to do. We're going to divide that by K. So P over K equal delta T, and actually this will be a minus because I look at the force direction, delta P. And with that said, we can do P divided by K equal thermal expansion, which is given by this equation over here, alpha L delta T. And then this will be plus by PL over AE, and this should be negative because it should be the opposite of that direction, so forth and so forth. And you can see there's two P's, and that's important. That's where everyone screws up. That's the one thing you need to know. So when I do PK minus P plus PL over AE, that is the key. A lot of people doesn't realize that, and they mess up the problem. That's the hardest part of this question. So P 1 over K plus L over AE equals alpha L delta T. So P equal alpha L delta T 1 over K plus L over AE. There we go. So isn't that beautiful? All right. So we have to plug the numbers now. And I should stop calling it plug and chug because it's no longer considered plug and chug after you do all that stuff. And luckily it's 1 over Celsius, so the only thing different is the 10 then, okay? So let's just do division. 11.7 times 10 to the negative 6. Multiplied by the length, which is 5, multiplied by the delta, which is 70. And then in this parentheses, 1 over K. What is K? 2 times 10 to the square root of 8. Plus division. L is 5. A is what? 0.01. Multiplied by E, which is 2.1 times 10 to the 11. Or you could do 210 times to the 9. I actually like that better because it gets you in the practice of some of the questions where you have to know that G means 9. I get P equal 554,806 newtons. And is this one because it's kilonewtons, so you have to divide it by 1,000, which is 5548, which is rounding up, which is why they did it. So it's A. All right. Next question. In which of the following steel structure shows would a temperature change produce an internal stress disregardless of the thermal roll again string? Well, it's kind of obvious what it's going to be. It's 1 and 4 because this has free movement up, so I don't need to think. Let's see. Next question. All right, so we're going to do this equation, and the first thing we're going to do is the global shenanigans again. So globally, we look at the exterior. We're not looking at interior. Interior is later, okay? Why are we looking at interior? It's because Obviously, over here, A is not solved. That's the real reason. There's only one reason. Anyways, right now, we can also create the moment diagram and do the moment, but we don't need to. So just think about the forces for a bit because we don't want to do moment and I don't want to do moment. Basically saying less work is good work for this one. It's a multiple choice question. I'm not willing to do another 5 minutes doing the moment diagram. So instead, let's do the shear diagram real quick and explain how you could actually figure everything out. So first of all, we start with this. We start with this diagram. And we understand that we're doing a summation of f. So we can do the summation of f equals 0. So this is ay. So ay is going to be positive plus 5 plus 10. It's going to be minus 2.5 multiplied by 5 divided by 2, but there's two of them. So it can be 2.5 multiplied by 5. And that's it. Equals 0. So ay equals 15 minus plus 2.5. 5 is basically it. Grab your calculator. And I get 2.5 and then minus. So here we solved one of the unknowns that we need. Was it 1.5 or 2.5? Yeah, it's 2.5. Minus 2.5 newtons. With that said, does that really give me anything I need? Not yet. Ay equal 2.5 newtons negative is just the first step. Second step is basically look at this, right? And we're going to cut over here. And we're going to realize we're going to start off with, if I look at this direction, minus 2.5, which is going to be like this or this. Now, these two cannot be the answer because these lines are linear, which means that this has to be linear for it to even make sense. And since they're not linear, we can cancel those two out. Now, with that said, we can look at point B, but we don't really need to. What I'm going to do instead is look at a certain point, like region 0 to 1, and do an integral over here, and we're just going to do it straight up. You can do a concave up analysis and do it, but let's just look at A to B. Now, how we will do that is interesting. First of all, we have this line over here, right? So this 2.5 is always active. Understand that? That's always going to be active here. When we cut over here, over here, over here, you're going to have a positive 2.5, and then you're going to have this portion over here. So what we're going to do is basically make it into a line. So over here, we have negative, and we're going to do 2.5 divided by 5x minus b, which is 2.5. It's positive b, sorry. So that means get your calculator out, do this. 2.5 divided by 5, which equals 0.5 minus 0.5x plus 0.5 is what we'll do. Anyways, and then we'll add in over here minus 2.5. Here, yeah. You might be asking, what am I supposed to do with this information here, right? And you would be right to say, like, yeah, I get this, but there's something you're supposed to do with this, right? So what we're going to do is go in here and grab this equation, which says negative dv x dx equals weight x. What that really means is that if you take an integral of v dx, vx dx, that must equal, wait, sorry, integral of weight x, that must equal negative vx, is what it's saying. And with that knowledge, I think you understand where I'm going with this, hopefully. If not, well, just watch and see, right? So with that said, we go back over here. I guess this doesn't matter anymore. We did integral 0 to x negative 0.5x plus 0.5 and negative. We already know, and then there's negative 2.5, but that's from this. But we already know that from previously. So we do this integral. We'll get 0.2 divided by 2x squared plus 0.5x. And then it's going to be minus, minus, plus, minus. So in the end of the day, we get this form. Okay? Now, you might be wondering, what region is this valid for? So 0 to B. So A to B is valid. Now, remember what S squared is. X squared moves like this. So it must be concave up. Therefore, this one. But imagine if it's a more complicated version. What would you do? Take a derivative and take a second derivative and get the maximum and do that critical point analysis. But we don't have to do it for this. I'm not doing it. Be lazy. If you're gonna do something, sometimes it's sometimes worth to be lazy. There's no reason for you to pull your heart doing this. Now here is a shear diagram for a simplified support beam. Oh wow, we're going to do another integral. If you don't know, look over here. There you go. There's your answer. Same thing as this, just do it. Now, as you can see, there's moment one, moment two. That's the moment in the end. the beginning. I'm assuming that there's no moment extra. So I mean, it should not show up. So what I mean by that is basically there's a case where there's a moment over here. So therefore there's like a jump over here or something like that. In the next thing you have to do a different integral, and that's what we did in the previous one. So over here, what are you trying to look for? The shear diagram for a simple first support is shown. What's the maximum moment in the beam? So in this case, we have to look for the maximum moment of the beam. So clearly there's a negative moment over here if I were to integrate this. So what you do is not do that one. You really want the maximum. So integrate this, and what we can say is put our A to B at a certain point over here, probably something like here over here. That's the max moment, and then that's it. Now, yeah, basically that's what I'm saying. And you can imagine how it's going to be. Integral 0 to x over here is just increasing with the Vx, basically, dx. And then you do integral 0 to x in this region over here, here. And it's increasing continuously, it's not decreasing. But then you start over here and decrease over here. So you can kind of understand how the beam location works. So now you can understand what I'm doing. So 4.8 multiplied the height multiplied by 44.8 plus 4.8. No, what's this? Multiplied by 100.8 minus 44.8 divided by 2 and plus 2.8 parentheses 100.8 divided by 2. And that should give you the answer. So it's moment max. So grab your calculator and multiply by 4.8 multiplied by 44.8 plus division 4.8 multiply parentheses 100.8 minus 44.8 divided by 2 parentheses plus division 2.8 parentheses 100.8 parentheses divided by 2 equals F max equals this equals 491. There you go. I got 490.56 actually, but we round up to 1, so there you go. That should be it. So there's a free body diagram. There's two forces over here. We're doing global variable first. We have to do that way. Otherwise, we don't get anything. And then there's a effective beam force over here. Now here's a little trick over here. We don't have to care about one of the direction, first of all, which is this one. This one is just 0. Second is that when we think about it, this is symmetric. So if I put a force down over here, we can imagine that the two forces over here has to be the same. And you can prove it mathematically by using moment and summation of forces, or you can just trust my word for it, which I do hope you do, because that makes things easier. So W multiplied by 10 equals about 800. And if I was right about the force over here, then the force is about 400. Now, why is that important? It asks for what's the maximum compressive force. The maximum compressive force, in theory, is first you have to get the maximum moment because it's going to use the my equation. We're going to cut in the middle then. And with the cut in the middle, the convention usually is down for the shear, normal for that, and then going this way out, this way is the moment. And now we have this equation over here that we can tend to. Much more simpler, much more elegant than what we had before, in my opinion. So what do we do now that we have this equation? We just have to. So from here, we can take a moment over here, and we're going to do the positive, and with the plus over here, it's going to be in the middle, which is going to be 80 multiplied by 5 divided by 2. No, divided by, sorry, not 2. Divided by 5 divided by 2. And it's going to be negative 400 multiplied by 5, which equals 0 at this point. This moment is going to be created. So let's get the calculator out and try to do this real quick. 80 multiplied by 5 multiplied by 5 divided by 2 minus 400 multiplied by 5 equals about negative 1000. M equals 0. So moment equals internal moment. This is called an internal moment equals about 1000 newtons per meter. So with that idea, there's called something called a my equation, which creates the maximum force over here. And there's a neutral point over here, which is going to be over here. It's going to be 1/3 the distance of that. I need to figure out h first, but that's not the problem. But you might be asking, where did this equation come from? Did I get it out my ass? Let's see. Over here, there's one. But I don't remember that being the right way. I don't think that's right because it should be plus, in my opinion. I always was taught plus method. Why is it minus here? I don't know. Either way, it doesn't matter. I wasn't asking for magnitude or anything like that. You don't have to worry about it. Just use it and you're done. Okay, so secondly off, which eye is it? Is the eye of this or is the eye of the whole beam? It's a good question. It's obviously a question. So in reality, what you have to do is go over here and is the eye of the whole of the triangle actually, because I'll tell you what's happening here soon. But first, we have to go get the triangle version real quick because otherwise, I'm talking to a rock and I don't know if you know everything or do know everything. So I need to go all the way up here to the triangle method because I actually don't know what the eye for the triangle is either. So go all the way up here, go over here, realize it is B over H. So I is equal to saying BH3 divided by 36. And that is at C, which is what we're looking for. And the C is and then the H divided by 3, as I said. So we need to get the height of this. And you can imagine that doing a right angle over here, we can do 10 squared, okay? And then minus 6 squared equal whatever rest. So and the square root of this. That's just Pythagorean theorem. Second square root. And triangles are king, as usual. And minus 6 squared equal about 8. We'll say cm. So 0.08 is what's going to happen in meters. So you can imagine that this is 0.08 divided by 3. And that is about in the C. Oh, wait. C is whichever, I mean, it could be, sorry, I'm wrong here. So here's the thing. It is not C yet. What's happening here is that C is either this one or this one. And you have to figure out which one is max. And to figure out which one is max is actually 2 divided by 3, by the way, if you didn't know. It's the one that's going to be because if you think about it, I'll tell you right now. This max is equal to, I mean, sometimes you have to calculate it, but here's 1,000. And then over here, um, if I did this, if I did just this, what would happen is that you would be creating something, how do you say it? It wouldn't be the correct answer because it's not max. There's another point up over here that's at a um, higher moment stress. What's it called again? Compressive stress. So B is 12, looks like. Height is about 0.08. And don't forget to change this all into 12 divided by 100 because that's 100. Height is cubed apparently, and then it's 36 apparently. So if you grab your calculator now and do 1,000 multiplied by 2 divided by 3 multiplied by 0.08 parentheses, and then you do this, and then 12 divided by 100. Why is it not giving me 100? My apologies, but my calculator seems to not work on that one. I don't know why it's not putting 100 down. Okay, 3. Oh, now it's working. Okay. I get 3,125,000,000. So that equals 3,125,000,000, which is uh 6 zeros, so it's mega. So you just do 31.25 megapascals. As you can see, that is that. And we can finish it like this. Now you might be asking, well, God, geez, this is such a no. You might be asking the earlier question. What about over here, right? Because technically, that's just plug 1 divided by 3 here, and you get a less version. Obviously, because this is greater than it is on the top, it makes sense it'll be greater. But yeah, actually, I don't need to explain anymore. You guys are all engineers. You guys are just even if you're watching this, you're only watching this as a review. You already done all this before. So there you go. That's the all right. A cantilever beam is loaded with a triangular displacement load as shown. What is the deflection at the free end? So this over here requires the knowledge of this equation over here. So you're gonna actually bring up this equation and just use it. So it's down over here in the gutter of no, not the gutter, down over here at the end. If it I don't know where it is actually. Over here, I think I saw it earlier. Ah, here it is. So deflection of the beam. So it's this. This is a deflection of the beam. And you can use moment, you can use EI. I think moment probably is the easiest one because look at this. This is a 4-dimensional equation. That means 4 different integrals over here. I don't think anyone wants to do that. So in the case differential equation of deflection of curve, you probably will given d squared y dx squared equal m. And you just have to get the moment equation here as and do 2 integrals from it, and you can get this. And there's a plus c, that's plus c, but most likely what you're going to do is boundary condition. And I already see the boundary condition over here. The boundary condition A is 0, basically. Anyways, with that said, with that in mind, we can now do moments over here. And we need global moments first. As always, we do global moments and global, yeah. So we can just do MA, and we can just do summation of Y. And then we can do all the fancy stuff. Okay. but you get the point. So this is most likely the way they want you to solve it, but I'm going to solve it a slightly different way. There is a differential equation called this. Now, this is definitely not a way that usually people recommend solving it, but in this case, I think this will be easier. dv x dx, or I don't know, it's minus w. Okay? So what we're going to do, equal, oh, equal minus w. We kind of have a w over here. So we can solve this by just doing this, literally, from a point, basically. This is not the traditional way, and I wouldn't recommend it to most people, but we can do d4y dx4, and that equals d4 over here. Oh, no, d4 is right. d4, and then minus. So minus this, so it's minus omega over lx, basically. Omega over lx, right? And then we can do like four integrals on this one, dude. So wait, divided by 1 divided by ei2 over here. So we can do integral 1. So that gives you y3 divided by dx3 over here. I don't know why I put a 3 there. And that will give you negative omega over L. And it's going to be x squared divided by 2. And it's going to be 1 over ei equal plus C1. And C1, you go over here and realize that is doing this. So it should equal V. And V at the free end equals 0. So if at L equals 0, we can plug L over here. Omega 2L, L squared, 1 over EI plus C1 equals 0. So C1 equals whatever this is. Cancel this one out, cancel this one out. I think I get something like omega L divided by 2 EI at the bottom. We might actually we can just put EI over here. So yeah, like this. Now we will do the faster way later on, eventually, when we get into that later on. But for now, we're gonna use a shorthand way because it's kind of easier for us right now. Minus, so it's minus plus now because it's plus omega L over 2. So that's the second one we did. Now, is this the traditional way? No, this is like the hardest way possible. The easiest way is to get the moment diagram done, but I'm too lazy to do that. And actually, no. Honestly, I just have to review it. I just don't want to right now. So we're just doing the hardest way possible. And then we're going to convert that to ei dy squared over dx squared, which equals minus w over 6lx3 plus omega l divided by 2x. As you know, that is the next one. And then you need to do plus c. Excuse me. And I can just say over here, I don't know, double prime equals 0 again at L. I mean, they don't imply that there's a derivative, right, in the dx dy. All the derivatives, there's no position movement basically in it. Yeah. So we can just say 0 equal negative omega over 6L L square L cubed plus omega L divided by 2 L plus C2. You know what? I don't recommend anyone do this method because this method is actually pain in the butt. But since this is the method I remember for doing this method like this, in the future I will review my other methods probably later today when I read the actual more of the book. And then we have equal C with the minus over here. And I think I have to do this by hand, unfortunately. So yeah, let's get this out of the way. Um, I get I think I get 2L squared divided by through 6, which equals negative 1 divided by 3 omega L squared. So that would imply that this one over here, uh, we can delete that now, it doesn't matter. di dy squared dx squared equal negative omega divided by 6L. I should probably remember to put it there because my brain is always like foggy on that. I don't know why. And then minus 1 divided by 3 omega L squared. Yeah, very inefficient way. We're slowly climbing into the answer. We will get it eventually. Obviously, this will take like 6 minutes if you do it this way. There is a faster way that I need to review, and I will come back to you when we do that in another question, because there's a whole entire section of these questions that we'll do later. So anyways, another integral over here. So we just have to do another integral. So negative omega divided by 18. No, 24, sorry. Lx4 plus, I can barely read this, omega L divided by 2, so it's 4, x squared. And yeah, this is going to be Last one, I think. WL square x. So plus c. And now we just have to get another integral in. But again, this one, I think we can just put this being 0 at the end. So in this case, we could just do that. And then last integral is negative one more of this to get basically in this form, which is v equal, no, y equal negative omega over, all right, 4 multiplied by 24. I don't know what that is. 96 Lx5. Oh, not 24. I am so blind. 120 because it's 5. Plus omega L divided by 8. No, not 8 again. That's 12. 3 minus 1 over 6 omega L square x squared plus C4. And again, we can just say deflection here is 0, so this goes away. So this is our answer. God damn, now I have to put L in everything. Negative omega over 120 L, L to the 5th power, plus, did I do something wrong? I don't know. I think I did something wrong. I will just go for it, but L to the cube minus 1 divided by 6 WL to the 4th. They all should be in the 4th power. Why is this? Oh, there's a bottom one, so it's a 4. Okay, so this one obviously go to your calculator and multiply the coefficient in your calculator. So minus 120 plus 1 divided by 12 minus 1 divided by 6. Okay, I get 11 divided by 120 minus. So omega L4 divided by EI is all you need. So that's A. Now, do I recommend this method? Hell no. Please, I'm going to review the easier method. This will take me 5 minutes per test. So I don't recommend this method, although. A beam is simultaneously loaded by a pair of eccentric 100 Newton force and a 50 Newton per meter moment. Neglect buckling effect. What is the maximum compression stress? So we're doing omega equal F over A for this force, and then plus my equation. My equation. Now, with this equation, I will definitely say that it is not normal because we're going to have to use, well, this is going to matter basically. So let's just figure out where the moment is. We have to figure out the moment, which is 50, and then you have to figure that out because this is easy. 1,000 divided by area, which is going to be 0.25 multiplied by 0.75. That's fine. The question is this one, plus or minus also, because we have no idea if this is better or this is better. Last time with the triangle, I can tell which one's better. But this doesn't know. So hmm, I think the best way we could do this is put the moment on the edge over here because this is universal. So I can do, and this is minus direction, so 50 minus that. And then let me look at this. Oh, this is 0.2. I don't get the notation here. I think they made a mistake in the notation. Let me check on the original, like how they do it, because I think something is generated wrong again. Yeah, that's why I was like, this doesn't make sense. Yeah, okay. So apparently this notation is supposed to be like this. So yeah, no wonder the question didn't make sense. I was about to say like what's going on there. But um I was about to do a moment on this side, and I was like, what's going on? That's not normal. Instead, you're supposed to do a moment on the neutral axis because that's how you do it traditionally. So 50 minus F, which is 1,000 newtons, multiplied by 0.2. And then the C is multiplied by the highest over here. So 0.75 divided by 2 is over here. And that is C. Divided by I. I believe is, do I want to make a guess and say is this? Or look it up. I'm just going to assume it's that. And if none of the answer choices is that, then I messed up. 2 minus 50. Wait, multiply. Okay, I'm just going to plug into my calculator because I have all the units. I just need to plug in and figure it out. And again, make sure you have all the units. That's newtons, meters. Okay, we got it right. So 0.25 multiplied by 0.75 plus divide 1,000 multiplied by 0.2 minus 50 divided by this. So base is about the 0.25 multiplied by h, which is 0.75 cubic divided by 12 multiplied by C, which is 0.375, which equals that. Okay, that looks pretty big. And let's look at the other one. If it's minus, okay. Obviously, this is bigger, and I get the answer D. I get about 11,733, which is what 11.7 round up to 12, so it's 12. So we're just gonna assume that is a round up thing and do D. I could tell that this section is gonna be the hardest to do for all of us. A symmetrical pin connects truss that is loaded at its midpoint at the midpoint, okay, by a vertical force Q. All members have the same cross section and are constructed of the same material. As the force is increased, what member of the truss will buckle first? Oh, buckle question now. Interesting. Okay. Buckle is not what well, I'm questioning this because this is just basically solving for compression and which one is compression first. And after a quick analysis of that is basically just plug and chug to like our one of the equations over here. Where's the buckling section? Is it this one? I don't think so. That doesn't sound. That doesn't. I'm looking for a specific buckling thing. Beam subtractive buckle. Okay, I can't find it. So here it is. Column axle load and the buckling. Here it is. And this is the equation we're going to use. It is basically where critical happens, such as the buckling for KL parentheses square. And this is basically you're going to use these, which yeah. So we're gonna have to figure things out here. First, we have to figure out where that global variable is, but I can already tell what's going to happen here. Globally, this is going to be q over divided by 2 without even thinking because it's symmetric. Again, if you're going to give me a symmetric question, take advantage of the symmetry. Do not bullshit yourself and think you're smarter than everyone else and derive everything. Just accept that as the symmetry works and move on. Do not try to do some kind of bullshit and try to prove it because you need to concretely know it. That's when you do it in class. That's when you're doing it in a long format question. We're not doing that shit here. Again, do not do that. That's a big mistake. Anyway, we're gonna cut here then. Cut. But notice something. Notice the beauty of this, and notice that basically the force on QA and Q and H is the same. Same. Thereby, you don't need to care about it. So throw that out. Second, this has zero forces. So whatever that happens, if there's and even the question says it has zero forces. Okay, so we know those have zero forces anyway, so just delete them. And over here, we start with probably pin A, which shows something like this. Okay, now here's the thing. We already know what this has to be, which is Q over 2, the opposite direction. Since that is, so it's going to actually be this direction. So that's an internal. Internal this, right, is compression. And for buckling to happen, it must be in compression. So AB can be in compression. No doubt about it. No doubt. Now, if this force is that way and this force is that way, this bar must be in tension. So AE does not matter. Delete that in the discussion. It's not even in the question bar, so I shouldn't even think about it. My apologies. So that means that can be applied. So we have to keep track of that one. Okay? We will keep track of that one for later. But for now, let's just well, we should try everything. Um, even if I have a feeling I know which one's gonna have the most compression. I think it is definitely not this one, but we have to use everything and try everything. So we can now. You want me to give me? You want me to give me a 2 cents? It's moving this way. We know is this right? So this, if this is also in compression, which means this is pushing that way, this must be in compression. This must be in compression. But the thing is, we know that this one doesn't work because if two actually, yeah, this is in tension, this is in compression. So it's either going to be B or AB because this is in tension then. This must be in tension. So BE must be deleted and EF must be deleted. Um, so yeah, that must be true. You might be asking, why is this in tension? If you move down over here, it's going to compress. Here, that's why I knew that was in compression. AC is going to be in tension. So that one doesn't matter. So it's a battle between A and C. Already, we have eliminated two of the answer choices by just knowing your compression tension, how to delete stuff, how to analyze the trusses. Truss analyzation is pretty powerful, isn't it? With that said, we have this question to deal with. Either is it A, B, or B, D? I have a theory C because there's another one over here, but that's just me guessing. So that's just intuition at that point. That's not real math. So we just have to do the math on both of them. There's no question about it at this point. We know BE must be in tension too. So yeah, I just yeah. So let's do it. Okay, let's first figure out the force on this. Summation of Fx on the A we need to do. So if Q divided by 2 upwards, we have to do Y. Q divided by upwards is true, then we know that in the cosine, if you're doing sine, sorry, sine theta, which is about a 4-5 triangle, and it's 4, 5. So it's in the minus direction, right? Minus 4 divided by 5, what's it called again? We should really have a name for this. Force AB. That must equal 0. So force AB equals Q over 2, 5 over 4. Yeah, that's beautiful. Like, yeah, which is 5 over 8Q. Next thing we need to do is look over here and look at BC over here. Now that we know this has to be 5 over 8Q this way, which means that it's this way actually for this block. And we know that this is going to be in compression, so this is going to go this way. And we know this is most likely being in tension. And this tension block over here is this Q over here. And we know this Q by symmetry has Q over 2 in the Y direction. So we can again, my God, this is getting cooked, isn't it? In the Y direction is Q over 2. We know it because that's how it's supposed to be if you look at symmetry again. It's very much looking at symmetry right now because I want to shortcut it. Earlier we didn't do symmetry, but right now I just wanted to shortcut it. If that is true, then we can do summation here. And this is basically doing a bunch. Which way do you think is the fastest? Well, we need BE, and BE, let's just figure out BE first, basically, is what I'm trying to say. And then we can figure out everything else later. Yeah. So, shit. What is this thing over here? This is a 4, 5. 4, 5 over here. And 2, 4, 5 of that, F, E, B. This is going to be summation of Fy at E is this equals 0. So this is 2. It's a positive direction. And it's going to be minus Q equals 0. FEB equal Q 5 over 8. Okay, so we now know 5 over 8Q is here. Okay. Okay, now basically we have to use x direction here. Fx equals 0. So it's going to be 5, 8Q, and it's going to be cosine theta. Cosine is what in all these directions? It is 3 over 5 in my opinion. So we can do 3 over 5 here, and it's going to be plus direction, and it's going to be minus FBD, and it's going to be plus 5 over 8Q, and another cosine 3 over 5 equals 0. So 5 over 8, well, both of them are 5 over 8. That's interesting. And then Q 3 over 5 multiplied by 2 is what they're saying, equals FBD. I don't know what that is. I'm going to look at my calculator and just figure it out. So 2, all right, division, 5 multiplied by 2 over 8 multiplied by 3 over 5 equals, oh wow, that's 3 divided by 4Q. Okay, we have it. We have the force. Okay, now, which one's larger? Which one's shorter? Okay, it doesn't really matter, I guess. We need to figure out this equation now, P critical. And it really depends on the bars used. So example, this over here means that this is 5 meters on the bottom square. And it's going to be pi EI over here for BE, right? And for the other one, it's going to be pi EI over, I don't know what it is, AB, right? BD, so it's 3, sorry. 3 square, this is AE, sorry. AB and BE over here equals PC, PC, PC. PCR. Now, C is unknown, right? So we have to actually reverse engineer it now. And I'm gonna clean a little bit over here. So it's a little cleaner because right now it's a hell of a mess. So let me just clean this over here. The logic is still pronounced in here somewhere. I mean, like it was a messy question. I believe this is actually one of the harder questions. It has trust, it has buckling, it has force analysis. So yes, this is probably one of the harder questions. So let me just erase all that. And then we can begin by saying f b d equal 3 divided by 4q, and b a b equals 5 over 8q, basically. And with that said, we have these two now that we have to play now, which equals PCR and PCR. All right. One way we can do it is basically make a ratio out of it. Um, divide both of them, is what I'm saying. Because if I divide PCR by FBD, it would equal pi EF divided by 3 square, and then 3 divided by 4 Q. So if I just got rid of all of these and just said that's just a constant and make it into, like, I don't know, another constant like J, we can just simply get rid of that for temporary reasons and basically just claim that as just a constant. And then AB next, which is pi EI divided by 5 square divided by, what is it? 5 over 8Q. And we can do the same thing. So basically, I'm saying, let's compare what is actually inside, which is 1 over, wait, so 1 divided by 3 square divided by parentheses 3 divided by 4, all right? And then that's about 4 over 27. And then we do the next one, which is 1 over 5 square divided by parentheses division 5 over 8. Okay, so this is about 8 divided by 125 pi EI divided by Q, and this is equal to saying 4 divided by 27 pi EI divided by Q. And from this information, we can see that is the answer C. And here's the indication that got me believing that was the correct answer. Even though that there was some buckling, this is a stopping point. These columns, even though there's zero member force, stops the buckling from happening. So this is a buckling over here, and this is a buckling over here. But I knew that there was more force over here. So if I imagine a bridge breaking, it would most likely be from here, in my opinion, because I usually think like this is N, and then this is how it would break in my brain intuitively. Intuitively, I think like this is how I would imagine something breaking in that point, which is why I thought it was BD initially, and that's kind of how my thought process was. But I was correct either way. We move on to the final question of the review overboard, which is 15. So a rigid beam BD is supported by a hinge at the NB and a pin connected structural link AC as shown. Point A is directly below point B. Member AC is a solid rod with a radius of 0.25. 0.025. The modulus of electricity AC is 210. The vertical downward force F applies at point D will cause member AB AC to buckle. Okay, fair enough. Okay, yeah, that's clear. So this is another Buckley question, and this time it is about AC. So we're gonna bring out this equation again. PC equals, what was it? Pi square EI divided by KL square. Honestly, I never used this before in my life, so that's new for me. I knew buckling, but I didn't know that equation existed for a long time. Anyways, with that said, what is this? A hinge pin shown member. Okay, maybe AC solid rod. Okay, so solid rod. So we can go to the statics section over here. So pi A4 divided by 4, basically. There we have it. All right, we have everything, unless I missed something, which is very possible, honestly. I'm gonna trust my instinct that we haven't, and just continue now. Okay, we didn't need K earlier because it was just a trust, but now we probably should go over here to the materials and go down over here to check the K's possible, because this is no longer normal. K over here. Pin, fixed pin, if and supports the theoretical effective values. Okay, yeah, I understand. Okay, so it could be, but unbroken race. Most likely. Yeah, we could do this. Okay. Um, that could be true. Let's just do this now. So I'm thinking we just do this now. All right. So first of all, pi e, we got everything. We have everything, right? We have all the newtons we can get, and then this is going to create P, C critical, and then we compute the force in AC to get AC, right? Yeah, force AC, and use that to see if it's P critical. And that's all we have to do. But let me just double check, because I'm about to do 5 meters and then square it. Uh, but this is not a normal thing. This is, uh, here's the thing. I'm pretty sure if I remember correctly, this thing is not just 5. This is a 3, 4, 5 triangle. Anyways, since I can't figure it out, it will just be 5 for now. And if it's not, then, well, none of the answer choices will work then. It would be, what's the length of this? 0.025 parentheses 4 divided by 4 divided by 5 square. And that's it, apparently. So go grab your calculator. And there's pi square multiplied by e, which is what? 2110 multiplied by 10 square root of 9 multiplied by division. Pi multiplied by parentheses 0.025 parentheses square root of 4 divided by 4 divided by 5 squared. What does that equal? Okay, I get something like 25435. And summation of moment is next. At which point do you want? We can do here, 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 basically. And that will get the force. But if I were to get the force on this one over here, I could figure out the reaction force on this and this, because this is 2 forces over here. And we can separate this into 2 parts, and we can get a reaction force there, so B. And then it's going to be, let's try to get a moment. So let's try to figure out the moment here. So AC over here is creating a moment this way, right? All the y direction is canceled out. So only this direction matters. So that is positive. So C, Y3, and then over here is minus F6 equal 0. So let's grab our calculator because we're trying to figure out, wait. Yeah, we're trying to figure out F. So we can do C, Y equals, is it just 6 divided by 3 F? Yeah, I guess so. No. This CY, oh yeah, it is CY. It is that. Yes, that's correct. Why is it not showing up again? This is right. But there's an extra step we have to think of. So 3. So it's 2F equal CY. But CY equals 4 divided by 5. So C equals 5 over 4, 2. Which, let's just use a calculator. Oh, wait, that doesn't sound right. 6 divided by 3. 4 over 4, 4, 4, 4. I guess that's right. I don't know. This doesn't seem right, but it's right. I can't think of a mistake there. So 5 divided by 2 equals 2.5. So C equal 2.5 F. Here we go. So with that said, we have PC, and PC equals 25435, right? 435, I said. Yeah, I rounded up. And then I can divide that by 2.5 equal F. So I can do that divided by 2.5, which equals, ooh, I got like 10,173 to divide by 100. So it's C. Oh, that was a hard question. The last few took forever to actually get right. So very hard question.